Good afternoon. I'm Anders Winberg. I'm Technical Fellow in the Enterprise Cloud Group, and I'm here to talk about our perspectives on security and assurance. Assurance we use sort of as an umbrella term to include compliance and governance and all the related issues. And here is the navigation slide you've seen before with the 4 introductory talks today, and then more stuff coming. And of course, you are here, right? So that's where we are in this discussion. And there are a number of other talks that you should follow up on with more details about this. I'm going to list these at the end of the talk as well. Now, if you're in this room today, I'm sure you know that the threat landscape has become very severe, right? We're not talking about teenage hackers anymore. We're talking about organized crime. We're talking about nation states, insider attacks with various motivations, activists, all kinds of complicated things. All of these companies have been hit, and hit hard, in the last few years. And these are competent organizations. Most of them have excellent security processes in place. If they can get taken down, we should all worry. And what is really more worrying is that a major threat is intellectual property theft. And very often we don't hear about those because those people don't see an interest in making themselves visible, right? So the real situation is much worse than this. But in addition to the change in the threat landscape, there are these interesting changes in the technology landscape that have a big impact on security. Virtualization, the shift to cloud computing, and by that I mean sort of large-scale computing, and then the whole service provider model when you operate in a public cloud or at some third-party hoster. Each of these have big impacts. Virtualization is interesting because we like to use hardware for security, right? We like to use a TPM. Most of our laptops have TPMs for managing keys for crypto. We like secure boot from UEFI, and a VM cannot use these because the VM is decoupled from the hardware. Now, the way we expose hardware functions to a VM, of course, is through virtualization, but virtualization is software. So how do we virtualize a TPM through software and maintain the level of trust that we have in the hardware? It's an interesting problem, right? In addition, VMs are mobile. So key management has to be mobile as well and has to remain secure. In general, VMs have a complex life cycle. Right? They get started and stopped and paused and migrated in the yard and all kinds of stuff. And we have to retain the security and not block those important scenarios. But it's not all bad news. Virtualization gives us an interesting isolation that is very good. Right? The workload is isolated from the hardware. In fact, inside Microsoft, we have a policy that a service cannot put a physical machine on the internet because we don't want that risk of an attacker going in and taking over the hardware fabric. So there are pluses and minuses here. Now, cloud computing is more complicated. There is this phrase floating around on the internet that you should treat your systems like cattle, not pets. Pets have names and you take care of them. In security, a practical example might be that you have a database with sensitive customer data, for example. And in the old world, you would put that on a particular machine. You would take real good care of that machine. You might put it in a locked cage. You would control who has access to it. And that goes completely against the principles of cloud computing. If you treat a server in that sort of pet-style manner, you don't get the economical benefits and the availability and scalability and global reach benefits that cloud computing promises. Cloud computing is all about management processes and at scale. And we have to come up with security solutions that work with that model. And we have to remember that cloud is not a building. Cloud transcends buildings. Right? We need the ability to migrate across multiple data centers for any reason from reach, business opportunities, disaster recovery, whatever. There's another element that is sort of related to cloud, but not exactly the same, and that is this whole experimentation model. At his keynote at Build last week, Satya mentioned an interesting customer we had of Azure, and it was 3M. 3M is famous for being sort of entrepreneurial, and they had some people who signed up with Azure on a Friday, worked over the weekend, and released a customer-facing survey product on Monday. Now, good for them. It probably wasn't perfect. The whole experimentation model means that they will measure and see how people like it and improve it. And that goes completely against classical thinking about governance. Right? Classical thinking about governance is designed for the old static model, when you plan and you build and you deploy a product and it stays there for 6 years. Right? We can't do that in this modern world. But we cannot think of governance and agility as being in opposition. Right? We can't. Some people talk about striking a balance between governance and assurance. Balance means that you keep the business people and the security people equally unhappy. Right? That's not the goal. Our goal is to find solutions that allows experimentation to coexist with reasonable governance. That's very challenging. And then, when you move to the service provider model, we have an additional complication. We now introduce a trust boundary between the tenant and the service provider, between the VM and the fabric, if you will. And we're not used to that. Our architectures have not had that trust boundary before, and they don't respect that trust boundary. And that introduces a lot of complications for us. And in particular, it may be even more important about compliance than about risk. What it means is that a tenant cannot extend the trust to the staff of the service provider for compliance reasons. Perhaps not for security reasons either. But even if you trust the service provider, many enterprise customers of ours tell us that they cannot do that because of compliance concerns. If we do not come up with adequate answers to these governance and compliance issues, the whole thing will act as an adoption blocker for the cloud, which would be very unfortunate because the cloud offers lots of benefits. We just have to find a way to work with that. One element of this trust boundary is that we end up with distributed accountability. If you look at this table here, you see the whole stack, from the hardware up through the operating system and the applications, all the way up to user account and policies. If you're operating your own private cloud, over on the right of the diagram, you're responsible for the whole stack. Right? If you move to a service provider, in an IaaS model, the service provider takes over responsibility for security of the bottom layers of the stack. But you own everything from the operating system on up. In the PaaS model, service provider takes over more, and SaaS model even more. But never quite all of it, right? As a tenant, you're still responsible for user accounts and access policies and so on. So in each of these cases, except the private cloud, we have this situation with distributed accountability. And that's tricky. We're not accustomed to that. In fact, there is sort of language in some of the compliance regulations that doesn't jive with any of these shifts. Like in Sarbanes-Oxley, for example, there is a regulation that the company has to keep track of who has access to the computer on which an application runs. What does that mean in the cloud world, right? Apps don't run on computers anymore. They run on fabrics, right? So who knew that regulations would embody the software architecture of the 20th century? But it does. So we have all kinds of interesting problems here. Now, if we drill down a little bit from this sort of high-level business focus and say, what are the actual problems we're facing? One thing we can see is the administrative privileges is the major risk factor. All of the attacks I had on that first slide involved exploiting elevated privileges, right? Either stolen privileges, where somebody got in through some form of attack, spear phishing or whatever, and then eventually stole some admin credentials, or there was an insider who had legitimate credentials. And then we have the concern about the service provider staff, even though I'm actually not aware of an attack that has taken that form. Nothing on that first slide involved a service provider. But the concern is there among enterprise customers. So we have to pay attention to the risk, if nothing else from a compliance and governance perspective. So this is real, right? The concern about admin privileges is real. And I think it's unavoidable for two reasons. The first is, it's easy for us as engineers to focus on zero days and clever attacks of this kind, and we can talk about anti-malware, and we can try to fix it. But we can't fix it because of human nature, right? We know that social engineering works. People can be fooled. We know that bribery works. You remember that scandal with the tabloids in Britain when they had hacked the voicemails of the royals and the police commissioner and all kinds of people? Right? The phone company actually had an excellent security system in place with a strong password that changed every day. So the tabloids bribed somebody in the phone company and got the password every day. They have plenty of money. That's not a problem. Right? We're not going to block that. And then you have people with private initiative who, for either economic reasons or ideological reasons, will leak it. Administrative privileges will be compromised. Number two is that 50 years ago in this industry, we made the decision to give the administrator the keys to the kingdom. Right? All distributed systems have this principle. I've been in this industry for a while. I had friends in the mainframe world who were appalled at that decision. That's not how things were done in the mainframe. But in our world, that's how things have been done. And we have built systems based on this model. And if we try to fix this, we'll break everything. So it's a problem, right? Admin privileges will be leaked, and we can't fix the vulnerability. So what do we do about that? Well, we have two principles that we use in thinking about this solution. Assume breach and explicit thinking about trust boundaries. Now, assume breach is not just a statement of pessimism. It doesn't just mean, keep your resume up to date. It's actually a form of rigorous analysis. Let me show you. If we have a big complicated system like this, we would normally protect it with a wall. But now we know that if the bad guys can get inside with admin privileges, the wall doesn't help. Right? A strong crust and a soft inside is not a good security model. So instead, we assume breach. We say, what happens if that system gets compromised? Oops, all of those other systems got compromised from there. And then we look at another one. And if that guy is compromised, all of these dominoes fall as well. And if this guy is compromised, the same thing happens. If you get this kind of pattern in your analysis, it's a problem, right? Because it means that any attack on one of these things will take out your entire environment, and the attacker has the freedom of movement across your environment. That's a terrible situation. What we want is internal protection so that an attack on one system is contained and the other systems are not taken down from there. So this form of analysis is very useful. Right? It allows us to go in and trace down what is the source of that contagion and figure out how we can block that. And you're going to see this principle in all of the solutions we're going to talk about today. Right? That we follow this assume breach principle everywhere. The other thing about trust boundaries, it comes up, I talked about the service provider and the tenant having a trust boundary and so on. It used to be very simple. Right? We used to think that there was a trust boundary between us good guys and the bad guys. Right? And that recent experience has shown us that the world is a bit more complicated than that. And we have to think about the three of us. Right? We already talked about the fact that an enterprise cannot trust the service provider, or at least cannot trust the staff of the service provider, right? For risk reasons, for compliance reasons, for governance reasons. But it goes the other way around. At Microsoft, we love our customers. We love the Azure customers, but we cannot trust the Azure customers because any one of those customers may be the Russian mob with a stolen credit card. And if a customer can attack the Microsoft Fabric, then from there they can attack all the other customers. So we end up with a mutual trust boundary here, right? And that's a novelty. In security technology, we usually have one-way trust boundaries. But here we need a two-way, a bidirectional trust boundary. That's not an architectural thing we have had before. And of course, with the governments, we love our governments, but recent experience has shown that that is a little tricky as well, right? It's a complicated story. And especially if you're in an international, multinational organization and have to deal with different governments in different countries. It's very complicated, so that each of these relationships involves trust issues. And all of this means that we have to be very conscious. We have to think about the trust boundaries explicitly in our architectures. And all of this is new. Right? Hierarchical trust models have been with us forever. Now we need non-hierarchical trust systems. It's a change. We have to learn to deal with this. So, with that introduction about the landscape and the shifts and the principles, keep that in mind as we talk about what we're doing about the situation. We're going to talk about 4 things. We're going to talk about how you protect the workloads from an attack through the fabric in the sort of cloud situation, how you protect workloads from direct attacks, and then on the assumption that the protection will not be perfect, we're going to look at detection, and then we're going to talk about the practical things we're doing to make these things usable and practical. So, fabric attacks first. We're going to use this diagram where we have the fabric with the hardware and the host and the hypervisors and so on. Then we have the workloads. We often call this the data plane because that's where the data lives. I'm going to just talk about workloads today. And then we have the control plane where we manage both workloads and fabric. So the fabric attacks I'm talking about look like this, right? Somebody with admin privileges get in either through the fabric and up or through the control plane and down. In order to deal with this, we're introducing something that I call the trust plane. And the trust plane is isolated from both the fabric and the control plane. And in that trust plane, we can put sensitive things like a key management system, for example. Right? And the isolation of the trust plane from the admin privileges in the other areas is central to this design. Now, you notice that the green layer here sort of slides over the host. We need a trust plane in the host. And how can we do that? How can we get reasonable isolation within the host? Well, there's a major new invention we are introducing here, which we call virtual secure mode. This is a separate address space in the host. It's isolated from the OS, even from kernel mode. It's enforced by the hypervisor using hardware, using the virtualization instructions in the CPU. And inside that virtual secure mode, the only thing we can run is a few small trustlets, we call them, small pieces of software that does security critical stuff. We don't run Windows in there. Right? There are no drivers. There's no network. You can't run any other software. And nobody has admin privileges in there. It's a very safe place. And like I said, the isolation is enforced by the hardware. Now, with this, we can, for example, protect a VM at rest and in transit using encryption. In effect, we can apply BitLocker to a VM. So let's assume this situation. I have a VM already sitting on disk encrypted. It's already been created. The key, which would on a laptop would be in a TPM. In this case, it sits on disk as well. But of course, the key, the virtual TPM in effect, has to be encrypted as well. Otherwise, somebody can just pick it up and unlock the VM. In order to start things, we do a secure conversation and a key exchange entirely within the trust plane, out of reach of the fabric and the control plane. So let me show you how it works. You decide through the workload manager to deploy a VM, to start it up. We reach down to the disk. We get the encrypted VM off the disk and give it to the host. We pick up the encrypted virtual TPM and put it in virtual secure mode, where it is safe. Now, the host can't do anything with this, so it reaches out to the key service and says, give me the key to unlock this thing. In order to do that, it hands over the virtual TPM. It hands over its own certificate that says, I'm a good guy, I'm a good host. And it hands over the public key to virtual secure mode. The key service says, okay, I like this, I accept your certificate, you're a good guy. It then encrypts the key using the public key of virtual secure mode, sends it over to virtual secure mode. We can unlock the VTPM, give the VM a TPM device in a normal way, and unlock the VM, and we're off to the races. Right? So the security of this whole mechanism of unlocking a VM came because of this secure conversation within the trust plane that nobody can get at. Now, it seems a little complicated, so instead of talking about it in an abstract sense, let me invite up my good friend Dean Wells, who will show you what this actually looks like. And by the way, as you see here, there are two talks going on. Dean will speak again, and then there's another talk today about Azure. Okay, Dean?
Thanks, Anders. All right, let me just bring this back over to the right monitor. There we go. Okie dokie, so Anders just took you through the complexities that underlie what we're going to be referring to from this point forward as a shielded VM. And there was a lot of complicated architecture on that board there. What I'm going to do is show you how that complicated architecture translates to a user experience. Now, I'm sure most of you can make a guess as to how that complex translates to this complex. So I'm going to try and make it as easy as I can by walking through it. So the first thing I'm going to do is I'm going to log on to the Azure Pack. Basically, I'm serving in the tenant capacity at this point. And the next part of my demo is I'm going to show you how I leverage all of that plumbing to create a shielded virtual machine. A shielded virtual machine is one that is protected from the Hyper-V admin by virtue of those technologies that Anders just outlined. So here's the portal rendering. I'm going to then go into here once it finishes painting. And by the way, the reason this is painting a little bit more slowly than we would like is because I have my entire data center running inside this. This is my data center. There's nothing remote here. It's a tiny little laptop with a rotating display and a touch screen. So it's actually doing quite well, so we should give it a break and not criticize it too much. So first part of the demo, new, standalone virtual machine, and I'm going to create a new machine from a gallery. Let me filter the view down so that you can actually take a good look at this. So I'm basically showing you just the templates that I've got now. And I look at the icons there, and you can see that there's a differentiation between them. These two, Nano Server and Server Standard, I'm sure you've heard about Nano by now. This one, however, has a shield. This is a shielded VM. So I'm going to show you how I create a shielded VM, which, as I said, is the result of all that architecture that Anders walked you through. Click on the corporate HBI template and say Next. Give it a name. Well, those of you that know me know why I'm using this name. Active Directory Domain Controller 1. It seems like a very good candidate for a shielded VM. Run a domain controller in it. That way nobody can gain access to the secrets. Anders mentioned the keys to the kingdom as an admin. This would be all the keys to all the kingdoms in the entire corporation if you were to get the secrets out of that. So this is a very good candidate for shielding. Now, the Active Directory domain controller would typically be owned by the IT department. So I'm going to select the IT department's shielding data, which obviously begs the question, what the heck is shielding data? Well, shielding data is this blob of secrets that you would not want a hoster to have access to. I can give you an obvious secret. What about the admin credentials? Imagine you created a brand new shielded VM. It was an Active Directory domain controller, and it asked you to type the admin credentials for that domain controller into a web UI that the hoster owns. That doesn't seem like it's as secure as you might like it to be. So what we've done is we've packaged all these things up in this big encrypted blob, and we upload them to the hoster, and then we give them to the VM in a secure way, again through VSM, so it's all encrypted through VSM, such that the hoster never gets to see the admin creds or the RDP certificates. Now, shielding data has a lot of other very clever things within inside it that we can talk about in later sessions. So moving on, I connect the shielded VM to a network adapter, nothing new there. Click on OK, and that was how the complexity of the architecture translates to the complexity of the usage. The one difference in that entire process was shielding data. Arguably, if you've created a regular VM through that UI before, it was actually easier because you filled out less forms. You didn't have to provide admin creds. So that's that one, and it's now going to sit there, and it's happily creating that. However, for the first few months, when you guys finally take this on and start adopting shielded VMs in droves, you're going to have VMs with hosters that are regular VMs. So the question is, can I convert a regular VM to a shielded VM? Well, here's a regular VM. You can see that it's... Let me go back and actually show you that's not shielded. There you go. You can see that it's not shielded. Click on LBI, File Server 1, go to the Configure tab, and again, to shield this guy, I simply click on Shield. This one is owned by the HR department, so I'll use their shielding data this time around. Click on OK, and that's it, done. So in terms of creating a new shielded VM, the only thing you had to do was specify the shielding data, which was pre-constructed by a security admin and uploaded to the hoster. But it's an encrypted package. They can't see its content. And the same for converting a regular VM to a shielded VM. It's just a matter of saying shield it and selecting the shielding data. So from the architecture, which was arguably quite complex, and it took us a long time to figure out, very cool though, it translates into a user experience that is very simple. Now, if I then come here, I'm going to take on a different role now. I'm going to serve in the capacity of a malicious hoster admin. And I'm going to show you what a hoster admin could do with Windows Server 2012 R2, or any other hypervisor for that matter. Because at this particular point in time, in that era of the market, we trusted the Fabric admin, we trusted the Hyper-V admin. So let me show you what happens when I attempt to mount a disk called PII data. Personally identifying information data. This is unshielded. This was created on a regular VM from 3 years ago. I mount it, I get it, I open it, I look at the admin passwords, and there's a file there called password.txt, very clever. I crack that open, and you can see my password is Mary Poppins, and Anders' password is Stockholm Rules, London Drools. I guess we know what Anders thinks about my country then. He already made a derogatory reference earlier on with his telephone company. Now we take a look at the health records, but it says the health records are blocked from my access. Is this a real block? No, I'm an admin on the box. This is an ACL. This is an access control list. So I can bypass that at any point I want simply by taking ownership of the folder and then changing the ACE and giving myself permission. And I can then crack open the health records, and you can see here that it says that Anders is, again, more sprightly and lively than Dean is. So that was incredibly simple for me to gain access to that. What about with a shielded VM? I go to Action, I attach a VHD, Browse, and now I'm taking a look at today's world, or from your perspective, tomorrow's, from mine, today's, and I'll try and mount a shielded disk. And this says HBI file server shielded. I bring that one up. And it says here already it's BitLocker encrypted. I'm just going to ignore that. I'm going to open it. No, it says access denied. So let's try a different way. I'll try and do it from the top-level Explorer view. And it says here, no, it's got a padlock. I'll double-click it anyway. And it says at the top here, no, you don't have a key protector for it, so you can't crack open the drive. I think I'm a genius attacker, so I'll use the command prompt, because that bypasses all security. And I'll go to drive F, and it says, no, that's BitLocker. So there's no way that I can legitimately gain access to the content of that disk. I can walk off with it, but it's a secure, opaque, meaningless blob of nothing to me. So shielding, for one at least initial advantage, protects the access to the VHD from the admin. Let me show you some of the other things it does real quick. Here is the shielded domain controller running on the Hyper-V management console. So if you take a look at that, you can actually see that there are slight differences. Take a look at this domain controller. I can see a thumbprint for that. When I look at this one, I cannot see a thumbprint for it. That's because the video output of a shielded VM isn't permitted to be shown to the hypervisor admin or the hypervisor management console. If I double-click on this one, of course, I can bring up a console session to it. And now I've got the keyboard and I've got the mouse of the Active Directory domain controller that's driving this demo. If I try that on a shielded VM, come on, it tells me that you can't do that because we consider that a vulnerability, along with many other things. You could also consider this a tax that you might have to pay, but it's a security tax. Last but not least, we shut off many other aspects of what you would consider traditional access to a VM from a Hyper-V host, such as KVP exchange or key value pair exchange, and there are various other areas that Alan and I will be talking about in our session tomorrow at 3:15, which Anders will mention later. So last but not least, let's just go back to that web UI, go back to the top end and take a look at our two machines, and you can now see that in just a matter of minutes, I've built one, a brand new VM from scratch, and it's now shielded, BitLocker disk, everything is secure from the admin, and two, I've converted an existing regular VM into a shielded VM simply by saying shield and selecting the shielding data, which, as I said earlier, is a secure package of secrets that was uploaded from the tenant. Hopefully that made sense to everybody. Okay, that's my job.
So we will get back to the main guy.
Yeah, let me get out.
Oh, you are using the main guy. I see. All right. Thank you. So a couple of things we left out. The VM is protected on disk and in transit, not at runtime. If somebody manages to put Mark Rusinovich's sysinternals on the host or a debugging tool or something or a hacker tool, he can get into the VM at execution. He can't get into the trust plane, but he can't get into the VM. So we block that with a code integrity policy. Think of it as whitelisting for the host. Whitelisting, code integrity, we have that today, but an admin can bypass it. This you can't bypass because it's in VSM. as enforced by hardware. Another question, you go to a hoster, how do you know that they have all this stuff in place? They say they do, but they can just say anything in the portal, right? Well, enterprises tell us in their own data center they have implicit trust. They trust the environment. Fine, that's reasonable. If you go to Azure, the answer is certification, right? Azure has gone through a lot of very rigorous and very difficult certification processes from ISO, from US governments, from the European Union, the UK, and other governments, from industry trade groups like HIPAA for healthcare and PCI for credit cards and so on. This is very important because they go through not just technology but process. How do you run the environment? This is actually very difficult to pass. And it's a very valuable thing for you to see because you don't have to worry about studying whether it's really good enough for credit cards because PCI says so. But we're adding one other function, which is attestation. And the way that works is that we are adding another service in the trust plane. And what it does is that when you boot a server, we send over some data from that. We send over public keys from the TPM, which is the identity of the host, and from VSM, we send over a secure boot log. We send over some policy signatures and stuff. The attestation service looked at that and said, yeah, I like that. This is what it's supposed to look like according to my policy. It then sends back a certificate of good standing to the host. And that, in fact, is the certificate that the host needs in order to be able to request a key. So that means is that if you have a host that is rootkitted, it is automatically evicted from the cloud. It doesn't require any manual intervention. A rootkitted host will have a bad security boot log, it won't get a cert, and it won't be able to get any keys. Right? So it takes care of a lot of practical things. Now, there are more things we have to take care of, and I can't spend time to go through all of this. But these are like all of the life cycle events for a VM and a host. So we have to make sure that live migration and cluster failover and disaster recovery and patching the host, all of these things work at scale, reliably, and securely. And Dean will talk about most of those later. Now, the key thing I want to mention here is that trust plane is not just a technology, it's a pattern. It's a design pattern, and we are using variants of that pattern in many places. Right? Azure has the Key Vault, and it's used by ARM, it's used by SQL, it'll be used by encrypted VMs. Windows Server has a Guardian service, which is exactly what Dean was demonstrating today for the private cloud. And this pattern can be extended to protect other things. So what you see here is the first step in a journey where we provide really robust protection for a lot of things. But we're starting with the VM itself because that is sort of the root of trust for everything. All right, so this whole discussion was about how do you protect from that fabric attack. But workloads can be attacked directly, as we saw in that first discussion of Sony and Carnegie Mellon and all of those things. So that's what this attack looks like. Somebody goes in directly with admin privileges against the workloads. In fact, what I'm going to talk about could also be applied to the fabric or the management plane. But in any case, it's a direct attack as opposed to the indirect attacks we did before. Now, encryption, which we used in the previous case, doesn't actually help against a legitimate attack, right? If I'm authorized to get at something, things will be decrypted for me. It's useful for a lot of stuff, but it doesn't solve a key vulnerability here. The first step in this, of course, is identity management, right? Which is by Active Directory, and then Azure Active Directory and AD Federation Service and so on are so central to everything we're doing. Without good identity management, we're just toast, right? We're adding important functions here and there, like Azure now has extended with role-based access control, including for apps. And we have multi-factor authentication in the portal, and you can use MFA in other places. But those are key. That's fundamentals. Without those, we can't do anything. But it doesn't address this problem that you have these gods, right? The system admins that can get everywhere. So here we're introducing another technique that we call just-in-time and just-enough admin. And the idea here is that nobody should have unlimited privileges across the whole environment. In fact, nobody will. The people who need to work in your environment, they have one authorization, and that is they're allowed to go to a portal and request permission to do something. And when they get that, they will get a time-limited credential to work on a particular part of the system. It gives us two things. One of them is containment. If somebody compromises those credentials, they can go to one place, they can't go all over. And it gives us auditability, so that if somebody goes in and requests stuff to pick up documents from all the SharePoint sites in the whole company, you can begin to wonder what is going on. Again, I don't want to do a theoretical abstract discussion here. Let's have Mark come up and show us how this works in reality. Come on, this picture is not good. So as before, there is a deep drill-down session where Mark will go through this in more detail. And you need to switch over there.
Thanks. Here's to switch the monitor over. Should see it momentarily. Oh, sorry, wrong button. 2. Great. So what I'm going to show now is some of the features we're bringing into your private cloud environment with Windows Server, with Identity Manager, and also what we're going to be doing also in the Microsoft Online Services with Azure Active Directory. The main problem that we see in so many organizations is how many people have administrative privileges. So here I am, I'm an ordinary user, and at some time in the distant past, maybe I worked in the IT department, or maybe I called up Help Desk one day and said, hey, Help Desk, I need to be able to log into this server because I need to restart the web service where my app is running. And so what did they do? They helped me out. Help Desk helps people. They helped me by putting me into a highly privileged group like domain admins, because that was the easiest and fastest thing for Help Desk to do. Great. Now that person will never call again asking for permissions. They're in there. They can do whatever they want. They don't need to get any more help. Well, that's, of course, a problem, because what happens if this user's account gets compromised? So someone's going to go do a spear phishing attack, find this user through the directory and say, hey, this user looks like a good candidate. We'll attack them and steal their credentials or somehow run something as them, and now immediately the attacker is an administrator. That was a problem. So what do we want to do? We want to help you in your organization reduce the number of people who have these administrative privileges and aren't really using them 24/7, 365. We want to say when Jen goes and tries to use her account and log in here, she's not going to be able to log in. Why? We want to take her out of the highly privileged groups. We want to make it so that Jen and everyone else in this environment is just an ordinary user, so that if that user account gets compromised, malware is running as that user, can't go and spread across the network. Instead, we're going to give users an experience to go and take on the privileges that they need at the time they need them. So here's an example portal that we have in Identity Manager. Now, the web portal, but this is just JavaScript. SOAP API, REST API, PowerShell interfaces. You can embed this into a lot of different experiences you have today. So what I'm going to do is I see now here's my user Jen, what I'm allowed to elevate into. I'm now an ordinary user, not in any highly privileged group. I've been given by the other administrators the ability to elevate into a group, corp admins. Great, so I'll do that. And while this is going on, I have to give a justification. I'm demoing for Anders. Great, and a timeout. So I'm not going to be a permanent admin anymore. When I need to do something, I need to reboot that server, I need to look at the logs, my privileges will last however long they let me, an hour, the weekend, a week, something like that. And then they're automatically taken away again at the end of that. So great, I'm going to go request elevation. Now there's no approval step in this process for this demo, but you could configure other approvals. You could say, well, I need someone else to approve. I'm maybe just a vendor. I need a full-time employee to approve it. Or maybe I'm going to do a stronger authentication check here. Maybe just having an account isn't good enough. Maybe they're going to call my cell phone or my desk phone. Am I really sitting there at my desk making this request and not having someone who's stolen my credentials and trying to request on my behalf? So good. I've now requested. I'm now in this role. It's going to expire in a little while, so I better keep moving. So what can I do? Well, I can do things that I could do before, right? I've now elevated. I can go into PowerShell. I can run various different things. Let's see. I could connect to a server. So great. I'm going to go and connect to a server. And great. It's all going to work. OK. So I could do that. That's all exciting. Well, what am I going to do when I connect to that server? as I said before, I'm not going to show actually connecting because you've all seen connecting to a server. What would I going to do? 99% of the time, I'm going to do the same thing which I did the last time I called help desk and needed help. My web server is not responding. Can you reboot it for me? Or can you just let me go in and reboot it? I need to check the log. I need to look at something. I'm doing a very repeatable action. And what we find is a lot of the users in our customers, and you can give me feedback in my session if this works for you, a lot of the time the users are just doing the same kind of activities over and over again with their admin privileges. So what we'd like to do is make it easier for the people then who need to do those to be able to do just that. So the first thing that I showed was just in time. I go and I request to be in this group for an hour. What does that let me do? Well, it could let me, if you wanted to, say I can go log into servers, I can go and RDP into things, but maybe that's still too much privilege. Instead, what it could allow me to do instead is just use a PowerShell session to get a limited view on my environment. So now I've gone into a PowerShell container with my privilege. What can I do here? Let's do git command. I have PowerShell commands. Now, not very many. I don't have the full set. I can't wander around the file system because there's no commands to do that. But I do have some that I need to use for my legitimate purpose. So let's say what I normally do is restart the website because the website doesn't seem to be responding. So I can do get service. Great. So I can do that, and I can even do the command which I always do every time I'm not happy with my website performance. I can restart the web service. Great. So it lets me do that. Now, the great thing about the just enough administration is you can be more restrictive. Maybe the only thing I'm allowed to do is restart the web service. So just because I'm on this box and I'm able to restart one service doesn't mean I should be able to restart other services. Furthermore, I'm not a domain administrator on this box. I'm in this container. I'm locked down. I cannot get from here and be an admin on any other system. So even if I somehow manage to break this jail, say, great, I'm going to go run rampant, I'm trapped. My credentials, my identity here within this container is locked to this system. So these are the two new capabilities that are in preview today for your Active Directory environment, the just-in-time and the just-enough administration. And we'll have sessions on each one of these. I also want to mention that while this is something you can do today with your existing on-premises AD, we also have these capabilities coming into Azure Active Directory. So Azure Active Directory, we just launched in preview this week, this just-in-time model as well. So if you're using Microsoft Online Services like Office 365 or Azure or Intune, you say, I've got too many administrators in the cloud, let alone on-prem, you can start doing the same thing today and say, I want to have fewer permanent administrators of my online services. I want someone to request when they need to administer, give a justification, maybe give a trouble ticket ID, and now I have a log. Who requested, what time, what were they doing, what was the trouble ticket, all that's logged, and at the time of the request, if they haven't re-requested it, will go away and they'll just be back an ordinary end user again. We'll have another session on that later. Thanks a lot.
Thanks, Mark. And by the way, we should add that this is a technique that we have used internally for quite some time in Azure and in other internal services. In fact, my view, we would never have passed all those certifications without having just-in-time. It took us a while to figure out how to make it a general service that we can provide, and that's what we're doing now. All right. In addition, there's a lot of other protections that we're doing. I can't spend any time on that because this could take other hours. Nano server is very important. You've heard about that. It shrinks the attack surface. We've had anti-malware and patching for a long time, but now we're doing a lot of things to make them more practical for servers and complicated distributed systems instead of just clients, with scheduling and cluster-aware patching and things like that. We are hardening the system against pass the hash and pass the ticket attacks by putting LSA into VSM. Very important. This, however, applies only to the new OS, to Windows 10 and Server 2016. The other functions go down level, but that one is forward only. And we're doing a lot of things to networking. So anyway, there's a whole area here. We can talk forever about security, but let's not. Let me ask this question instead. With all this protection, now we're safe, right? Nobody I've ever met in the security space would ever say we're safe. So let's talk about detection, right? Of course, we've had intrusion detection and forensic analysis for a long time, but we think the time is ripe to make a dent in that whole area because of the cloud model, right? First, we have an enormous number of data sources. We can collect data from the fabric and from workloads and from network and from storage services and other services. And we can look at user behavior. We can collect data from our anti-malware, which is keeping an eye on 1 billion PCs out there. We have an active anti-crime unit that gives us lots of data. We have collaboration with industry partners because most of us good guys are collaborating on this point. And there is collaboration with government. In fact, they just put in a new law about taking down barriers to that. And we can collect data from private and hosted and public cloud. And we get all this data. It is enormously valuable because there are many things that are much easier to detect from a large data volume than a small one, even though it's harder to deal with large data volumes. But you can find things out from large data volumes. And the fact that it's harder is not so much of an issue because we now have cloud scale. Right? We can now have a serious conversation about analyzing petabytes of data per day. In fact, we do that routinely. Our anti-malware team routinely does that. So we're accustomed to this data volume, and we have techniques for doing that. And in particular, we have machine learning techniques that allow us to do intelligent analysis about behavior here. And we also know we're not the only ones who are smart about this. So the system is extensible so that third parties can plug in and look at this. So we think that this is a very exciting time, and we're just at the beginning of a revolution in detection. But I want to show you right now, instead, rather than me talking about it, two interesting things we're doing in this area, which are both of them available as of today. So Joe, you want to come up first and show us? In the keynote yesterday, Brad mentioned the Operations Management Suite. Operational Insight is an element of that suite. It's an online service. And within that service, there is a security pack that is specific. All right?
All right. So before I start, I just want to ask how many people have seen the OMS keynote demo yesterday? All right. How many people love it? Can you clap? All right. This is awesome. I think this is going to be great encouragement for our engineering team to give you more good stuff. All right. So switching over to my demo. I can bring it over here. All right. So this is the OMS website. You can simply type microsoft.com/OMS, and you can get there immediately. So there's a free trial that you can try for free. And in this case, I'm just going to sign in. And it will just bring you right into the OMS overview page. Now, what OMS is, or Operations Management Suite is a unified IT management solution, which offers you a whole range of different IT operation solutions to take care of a variety of problems in your environment. But the basis of this product is the capability of insights and the ability to automate. So today, I'm going to talk to you about our insights capabilities, which allows you to collect massive amount of machine data into a single big data repository and allow you to do ad hoc exploration of the data, or allow you to retrieve, safe, known pattern of investigations that you have performed before. Okay. Now, you can see that I have many different solutions that I've added into my account already, but the specific solution that I'm going to talk about today is the security and audit solution. This solution is quite powerful. It combines many different data sources together, which includes security events, Windows firewall logs, patch assessment data, malware protection data, chain tracking logs, all combined that together to give you a holistic view of your state of security across your data centers, whether it is on-premise, in the cloud, any cloud, AWS, Azure, or you're using a hoster like Rackspace. We can monitor them all and bring that data in. So with this type of data, you can easily look at activities that is going on in your environment. So I can, for example, go into security activities. which then give you a list of all of the actions that have been taken across your environment. In this case, I'm looking over the last 24 hours. Yeah, let me just zoom in a little bit so you can see all the data in here, right? And so, for example, if I want to look at any process that has been created, I can just drill into that, and it'll give you a list of all of that process creation events. And if you want to get a summary view of the computers which has been performing this action, you can say group by computer, and it will give you a list of all the computers, slicing those millions of records together into a simple view for you. Going back, we also give you important security context. This is the part where we're combining the different data together. So for example, I can easily see the number of computers that are missing security updates right now. I can drill into that, look at the exact number of servers that is missing security updates right now. If I look at my domain controller here, which is missing some security updates, and that is definitely concerning, I can drill into that again to look at the details of which patch is missing. And we also give you links to actually give you context as to the exact patch that is missing and what is the impact and the context of that right from a single click. Now, what if you want to perform some investigation on certain unknown activity that is going on in your environment? Well, we got great clues that is presented in our notable issues blade in the account here. And so one of the things I noticed is that I got some suspicious executables that is running in my environment. So I'm going to drill into that to see what's going on here. I see a number of executables that is running in here that is deemed as suspicious. So I'm going to click into one of the ones that are rarely run to investigate a little bit more. So this executable is called freecoupon.exe. So it looks like maybe someone from marketing, just want to save some money on buying groceries, have downloaded some apps in here, and and got malware, potentially malware running on their system. So we're going to investigate that a little bit more. So what I'm going to do is I'm going to look into some searches that I have made ahead of time. And I'm going to see the child processes that's been created from this freecoupon.exe that is running in my environment. Okay, so one of the things I noticed is there's some regular executable that is running on this machine. But one of the things I realize is that is running an FTP client on here, and this machine shouldn't be sending data outbound. So the next query that I'm going to do is look at the outgoing traffic in this environment. And this leverages the Windows firewall logs. And so what this gives me is that a list of IPs in which this machine is talking to and the amount of data that is sending out to that location. And it's really weird that it's sending that much amount of data out to this particular set of IPs in here, right? So you can take this investigation further if you want and get to the bottom of it, or you can pass it to another analyst to investigate further. But I just want to give you a glimpse of the power of big data and log search that enables you to both get an overview of what's going on in your environment and give you deep down forensic capability if you choose to exercise that.
Great. Thanks, Joe.
Thank you, Anders.
It's very exciting stuff. Great. And then we will look at one more demo. Michael Dubinsky will come and show advanced threat analytics, which is a very focused product that looks for specific attack patterns. I'll let Michael talk about it, and you have the slides right there.
Yeah. All right. Can you hear me? Yeah? Okay. So thank you very much, Anders. I'm Michael Dubinsky, Program Manager at the Advanced Threat Analytics Group. So the first thing I want to ask is how many of you were at the ATA deep dive session? Okay. So not a lot. I don't have a lot of time, so I just was trying to figure out what can I skip and what shouldn't I. So we're going to talk briefly about what ATA is, and then we're going to actually play the role of an attacker and do some attacks on our environment and figure out how can we actually detect those. So what is Microsoft ATA? So the product is basically a user behavior analytics product that analyzes information from multiple data sources over time, learns the behavior of the users and the entities in the organization, and eventually detects and alerts on suspicious activities and abnormal behavior. This is how the product works. So basically, we focus on the first thing, which is one of the most important things in everyone's organization. So with a show of hands, how many of you use Active Directory as the primary identity provider? Can you look around? No, keep the hands up and just look around yourself to see. Yeah. I think it's like 95%. And that's the situation, yeah, we all know that. And that's the situation in most of the enterprises. So I guess you can see where I'm going with this. If Active Directory is one of the most important things in your organization, and we know that getting administrative access or privileged accounts with Active Directory actually compromises the entire environment. So the first thing ATA does is looking at all the network traffic going in and out of the domain controllers in your organization. You cannot fake network traffic. You can fake logs, you can clean logs, you can do a lot of stuff with log files. You cannot fake network traffic. So once we do that, we learn the behavior of the users over time, and we build an organizational security graph. So it's a technology very similar to Facebook, but instead of remembering who you liked and where you commented and where your friends are, we remember which devices you interacted with, which times did you work, which resources did you access, and who are your peers that work similar to you. And based on that information, we actually begin detecting abnormal behavior using machine learning algorithms. And once we've detected those, we actually alert them on a very simple and intuitive timeline, which you can see on the slide, and in a second you can actually see in the demo. And once you see the suspicious activities in the timeline, we have 3 types of suspicious activities we detect. We detect security issues, so things that are not necessarily attacks, but can actually make the life of an attacker much, much easier when they access the network. So things like using plain text passwords over the wire. Those are things that make attackers' life much, much easier. The second thing is malicious attacks. So things like pass the ticket, pass the hash. We can actually look at the network, and we can detect those attacks using the security research experience we have in our team. And last but not least is the abnormal behavior itself. So even though we always know that there is new malwares, there is new code, there are new techniques attackers use, every single one of them would show up as abnormal behavior because the user account, the stolen credentials, would actually act differently in the network than the regular user acts. So with that said, let's switch to our demo box. Okay, and basically in this box, we're at the scenario now that the attacker got into our network and he performed some lateral movement which got detected by the advanced threat analytics. So let me just show the UI as well. So we've detected some lateral movement in the environment, and the attacker got access to the shared admin server, which we can see here. So now the role of the attacker, he got access as a regular user account. He wants to elevate his privileges. He wants to get domain admin access in order to get to whatever resource, whatever VM, whatever file he wants in the environment. So in order to do that, from the machine, what I'm going to do as the attacker, I'm actually going to dump all the Kerberos tickets that we have on that machine. In order to do that, I'm using a publicly available tool called Mimikatz. Anyone can download that. And what happened now, I can see that in the folder, I have a bunch of files created, and those are basically the Kerberos tickets that were in that machine's memory at the time I dumped the tickets. So now, as the attacker, the next thing I'm going to do, I'm going to access the computer which I control. So in our example, without referencing any known attack, is the external vendor machine. And I'm logged in here as Michael Dubinsky, which is not an administrative account. And in order to prove that to you, I can actually dir into the domain controller administrative share and try to see what happens. So I got an access denied, right? This is what you'd normally expect from a regular user account trying to access C share on the DC. So I'm going to copy one of the Kerberos tickets I've dumped from here. And I'm going to import that Kerberos ticket using the same tool called Mimikatz. I just scripted all those commands for Mimikatz. And now I've imported the Kerberos ticket. So what we expect to happen is now that I perform the same dir command, I actually get access to the administrative shares. So this is how pass-the-ticket attacks actually happen in the wild. Now, if we switch back to the Advanced Threat Analytics console, we can actually see that in almost real time, and I really hope that it will happen by saying almost real time, we have the pass-the-ticket suspicious activity detected on the console. So, just in order to prove that it actually happened, I'm going to refresh the UI. I lost my mouse. This is what happened. OK. Found it, and I can see the identity theft using pass-the-ticket. So I can actually see that I have the administrative credentials stolen from the share admin SRV and used from the external vendor PC in order to access the domain controller. So now I'm a domain admin in the environment. I can add myself to the domain admins group. I can perform remote execution attacks on the domain controller. I can do a bunch of other stuff. And that's basically what Advanced Threat Analytics is. We detect malicious activities and suspicious activities, both from the network and using machine learning algorithms. Thank you very much.
Thank you, Michael. Great stuff. That is great stuff. Oh, no. I clicked on the wrong button. I'm sorry. I'm sorry.
Let me help.
Yeah. Yeah, you find where I was. I'm sorry. Yeah, you know where to go. It's right at the... No, that's the wrong deck. Damn. That's networking deck.
How about this one?
There, yeah, close to the end. No, wait, that's also the wrong deck. They all look the same.
This one is the right one. This must be the right one.
Is it? No. No, close that one. Just so we get rid of.
This one we close?
I don't know.
Oh, this one is red.
This one. Yes. Ah. You're too clever for me.
All right.
Good. Thank you. There. So just one thing I want to close on, right? Because this was all cool technologies. We're very proud of them. However, we put a lot of effort into making this practical, because this is a serious problem in security. If you ask the security experts, they will say the problem of unbreakable crypto was solved in the 70s. So why do we have a problem? Well, because it's too hard to use. Right? So the key principles for this project and the goals were, number one, we need to protect both Windows and Linux, because Microsoft loves Linux, and including down-level systems. It wouldn't do any good if the only thing we protect is going forward, because all of you have existing systems. So we put a lot of effort, and almost everything I talked about here today applies to existing systems. I called out one or two exceptions. Right? Most of this goes down level. Most of this thing, if it doesn't cover Linux now, will. Right? Number two, many of the complicated things we are delivering as cloud services, because it's easier to consume, it's easier for us to keep it up to date, because this is a race. Right? The attackers are smart and adaptive and malicious, and we have to keep up with them, and it's easier for us to keep cloud services up to date. Number three, we need to minimize the impact on the workflows of our customers, both the tenants and the service providers. It wouldn't do any good if I come up to you and say, I got this great new secure platform. All you have to do is change everything about your environment. Right? You can't do that. So you put a lot of effort into this, and you've seen this in some of these demos, and there are many more examples that you'll see in the drill downs, how we made it practical to live with this thing. And then finally, cloud consistency. You've heard about cloud consistency as an overarching principle for our strategy. It applies here as well. It's a little bit tricky, though. I want to be very clear. Some of the technologies that we develop need to be built first into the platform and then get adopted by Azure and get adopted by our customers. So in that case, Windows Server has it before Azure. In other cases, the technology is developed first in Azure, such as, for example, just-in-time. Right? Just-in-time came from there. We used it there for a long time. It's been really important. It took a lot of work to figure out how to generalize it for our customer base. So it's a point-in-time question, and there will be occasional leapfrogs. But the core principle is to keep these systems consistent. So that's what's been behind our thinking for the last several years. My recommendations to you now would be, for enterprises, take a look at how you can use these technologies to protect yourselves as appropriate. Right? Every customer, every enterprise I've talked to has a fairly conscious and rational risk analysis about which things need to be protected first and so on. So work this through. If you're using service providers and clouds, require reasonable assurance from them. And it can be anything from certification to attestation and whatever. Include complicated scenarios, like disaster recovery. You don't want to be secure and then lose security in disaster recovery. And use detection services, because whatever I say about protection, it will not be perfect. For the service providers, I would say offer these functions to your customers. From everything I've heard from our customers, I believe these are high-value services that a hoster can charge for. I think that's very interesting. And leverage Azure services where appropriate. And then for all of us, I would say, number one, buy the appropriate hardware. Even if you think you don't need attestation right now, buy the damn things with TPM 2.0, because within the life cycle of the server, you probably will need it. And don't forget, assume breach. Thank you, ladies and gentlemen.